In this particular video, we continue looking at our 5 important lemmas. I will need lemma 1, so I want to restate it. Lemma 1 says that if we have a group and A is an element of G, and we have this peculiar property that A triangled with itself is equal to A, then it turns out that A is actually equal to the right identity element inside the group. Our second lemma can be stated in English. And I want to state it in English first, and then I'll look at what does this mean symbolically. But in English, lemma 2 says, right inverse elements are actually two-sided inverses. Now, what does this actually mean symbolically? To translate this into symbolic language that we can work on a proof, we have to say that G is a group. And again, we're going to let A be any element of G. What this right inverses are two-sided inverses claims is this. If A hat is a right inverse of A that is promised by axiom 4, then what we also know is that A hat is a left inverse of A just as well. In other words, A triangled with A hat equals ER is going to be enough to imply that A hat triangled with A will also be equal to ER. And it is this statement that we need to prove. So, and we're going to use lemma 1. Well, let's get started on the proof. There's not much that I can do here. So what I'm going to do is I'm actually going to look at this, not this element. I'm going to look at this element over here. And the only way I know of how to prove something is a group identity at this point is to triangle it with itself and see if I get itself. In other words, I want to state our strategy. The strategy is that we are going to look at A hat triangled with A and triangle it with itself. And if this turns out to be itself, then lemma 1 kicks in and says that this element is actually equal to the right identity, and so our right inverse is also a left inverse. So let's look at this. If I look at A hat triangled with A, triangled with A hat triangled with A, I can rewrite that as A hat triangled with A triangled with A hat triangled with A, and this is by associativity. In other words, axiom 2. Now, what's sitting in here is A triangled with its right inverse. So I know that that's going to be ER. So this is going to be A hat triangled with ER triangled with A. And this is by axiom 4. A hat is a right inverse of A. And so that gives us that particular thing. But now what I want to do next is I want to stick some parentheses in by axiom 2. So by axiom 2, I can put those parentheses in. And now what I want to notice is that axiom 3 kicks in. A hat triangled with ER is just A hat. And so we're now looking at A hat triangled with A. And this is by axioms 2 to put the parentheses in. And axiom 3, ER is a right identity element, and it's sitting on the right side of that triangle. But now what I've got is the situation for lemma 1. So I want to make this very clear. We now have A hat triangle A triangled with itself is equal to itself. So lemma 1 kicks in and says A hat triangled with A is indeed going to be ER. And that completes the end of the proof. Now I do want to kind of summarize what we have actually done. We have shown that if I start with A hat being a right inverse, that this is enough to say that A hat is a left inverse. And so what this says is that a right inverse in a group is also a left inverse in a group. In other words, a right inverse is a two-sided inverse. So right inverses are two-sided inverses. And that completes this video.